very long-winded talk title was inspired by a bunch of news articles I read late last year with titles like, you thought fake news was bad, wait till you see deep fake images, this is where the truth goes to die, a lot of kind of very serious stuff. And these articles late last year made predictions about, one day certain things will be possible that we can only dream of right now, and then already those news articles are appearing 6 months later, that a bunch of stuff people said was still years away is now much closer on our horizon. So yeah, what is to be done when absolutely everything can be faked? So my talk will be more about what we can do as personal practitioners of data science. If you're lucky enough to work in a bank with that structure of way of doing things that Martin talked about, good for you. Many of us operate kind of outside that in the free, dangerous world of the internet. But let's start with a little straw poll. Is anyone who's a data scientist kind of wonders some days whether there's enough science in data science? Okay, so I'm not alone. It was just to see, am I alone up here or not? So what I'd like to convince you is this message, which is that this is the first reaction I had when I read all those articles about, oh my God, fake news, deep fakes, they're all coming for us and there's absolutely nothing we can do. Right? So what struck me was we're now at a point where data in an image can't tell you anything about the truth value of itself. And so what that means is the most important things you can learn about your data, right, which you need to do to use it effectively and ethically, you cannot learn from the data itself. So let me try and make that case to you. So the dream, here's some trends not approved by Gartner. The top is the dream that we're all out there selling. Oh my God, we're collecting so much more data. It's great. Algorithms are more and more accessible to less and less technically capable people, and the use cases for this data plugged into these algorithms are just multiplying, and so the potential value is just exploding. You will have heard some people already at the conference say, well, not all data is actually created equal. What if you don't have enough data on a particular group to actually make decent predictions about them? Algorithms are not intelligent by themselves until they're plugged together into a system, and then maybe you get something that looks intelligent, but there's nothing intelligent about a probability function in the middle of this model in your favorite programming language. And there's some use cases of all this stuff that make sense. So there's maybe like all these positive use cases and incredible economic value, but there's also some worrying things. I'm going to get you all worked up with the extreme case and then try a pivot towards your daily lives, because I know you guys aren't creating deep fake images, but it's quite illustrative of how far off the cliff we have driven without necessarily looking down. So what a time to be alive. Yeah, we can get this person to control that person's movement, that person to control this person's speech, this person to get that person make a particular facial expression. And I think this one on the bottom right is, a video. This is already old tech. This is already 6 months old. A video where Obama says something that he probably didn't say in reality. But if you've got the right technology and it's increasingly accessible, you can make anyone say anything on camera. This is not a new technique, right? So in the top picture, we have Lenin arriving in what was St. Petersburg after his exile in Finland. And there's Trotsky. And then after Stalin, Trotsky, the truth was changed, right? So people have been faking images for a very long time. How would you know after the fact that Trotsky was really there? You would have had to have been there, right? Or read something that hadn't been purged from the historical record. So we've seen this problem before, right? People have been telling alternative versions of stories for a very long time. What's changed? Well, in the past, to doctor a photo, you actually had to be quite good at stuff and have a dark room and very delicate kind of work. Now you just need to be a bit of a computer nerd and have a bunch of training images. There's now open source tools that let people who aren't data scientists or have no machine learning expertise, and it's certainly not at this conference, right, thinking about ethics and AI, to put anyone's head on anyone's body. It was actually quite difficult to change the entire image, right? So they didn't make Lenin like a foot taller, and an expert, right, can easily detect these manipulations if they look at the actual photo. What my hypothesis is that the ability to create new and more convincing fakes is running much further ahead than the brave souls amongst us writing algorithms to detect it. So more and more fake images, fake video are going to be created by more and more people, and there'll be a few research labs doing some great work trying to detect those with different algorithms, but they're going to always be fighting a losing battle. But one thing hasn't changed, right? Only those with an alternative explanation for what happened can actually challenge. Right, so if you were there or knew a lot of people that were there or knew that Trotsky was important to the Russian Revolution, then you might be able to convince someone that the photo was doctored. Right? What makes us look at a video of Obama saying something that we don't feel he probably said? Well, we have a lot of other data in our heads, right, on which to judge it. So it's a lot more accessible. The techniques have moved on and are a lot more scary on the surface, but the way to beat them is still exactly the same thing. So here's the most contentious thing. None of you are making deep fakes, but if you think about what a faked image or video is, it is just a stream of data, right? It's just particularly human readable when you assemble it in a particular way. Our sort of unique human brain machinery can say, oh, that's that thing, that's that object, that's that guy who was the president, and calls up all this information about the context of that object and says, no, he kind of said that because he never said anything like that in another video that I saw, so this is a very unlikely observation, and then we can discard it. But all of our data is like that, right? You know, not many of us as data scientists, particularly in the corporate world, actually participate in the creation of our data. We're pointed at some business problem in some database. It's like predict which customers will churn, predict who will default on their loans. So this is a big jump, but it's like if you add it all up, if you can put any head on any body, that means data can be tortured to produce many results, right? We've all personally tortured data over and over to try and find the result that we wanted and felt bad about it afterwards. Only some of us confess that on stage. What that means is that actually any data hides multiple potential spurious correlations, right, that are very amenable. They want to be tortured out of the data, right? Then they'll exist in the world. No inherent incentive to avoid torturing data, right? We want to find things. We're biased towards finding things and generating new knowledge. The more data we get, right, that triumphal statement, we're getting so much more data, this is amazing. It actually means there's a greater risk of spurious correlations, and then furthermore, that ability to find those spurious correlations is being pushed out to more and more and more people, which does make me think, oh crap, sometimes, because this is not a great situation to be in. It means any data set, from an image all the way down to a customer record, it can either be maliciously faked or we can unwittingly misuse that data to reach poor conclusions. Things that we might think that we can rely on, you know, so ethics and AI conferences like this, that's good, but all the people not doing this are in the room. So what can we do when we go outside the room to tell people who didn't come to this conference this warning? Explainable AI, again, if you know what that is and you're using it, you're probably not one of these people who are super at risk of making a really biased and unfair credit decisioning model, because you know how to check yourself already. We can't rely on a highly engaged, skeptical public resilient to manipulation. There are no incentives built in for data scientists to just do the right thing, whatever that is. And we also can't rely on data auto-revealing some truth, right? Because it can be changed, can be interpreted in lots of different ways. So there's no like, if you believe me that this is a bad situation, none of these things are just like silver bullets that get us out of jail. If only something could save us. So what I've been trying to convince you is data by themselves have no meaning, right? We have to compare them to something else. If only there was a systematic methodology for comparing data to something outside it to understand how useful that data is to explain the world. Luckily, it's the second word in the profession, data science. science. So we talk a lot, and other conferences talk much more than this one about data, data, data. Oh my God, the greatest algorithms, even better Kafka. Let's just get more and more data, and all of these problems will be solved automatically. We have to use what science gives us if we've got a hope of, as individuals, right, coming together as teams and overcoming some of these ethical dilemmas, because there's no inbuilt incentive for us to do that. So, in the time left, so my background is as a academic social scientist, so studying human behavior and using data to do it. Turns out that's quite portable to the corporate world, because most consumers are humans, and so most businesses are stuffed by humans as well. So here's an algorithm, a very simple algorithm for practically using things that you've heard before in lectures about science in your day-to-day practice. So these are in order of if you can do one, that's amazing, and you'll probably never have ethical AI problems because you're thinking so deeply about what you're doing, down to this will help, but it's not as good. So the basic cell here is the more systematic prior knowledge you gather, the better, right? Because then when you see data, as you investigate stuff, you have something to compare it to. You can't compare the data to itself, right? That doesn't, if you believe what I'm saying so far, that doesn't really tell us how good the data is for a particular decision. So we need to gather prior knowledge, other data from outside the data that we're looking at for the job that we're doing. And the more we can get of that before we begin, the better off we'll be. So, what is a theory? Again, you have heard all of this before in your science, stats, applied research, whatever classes, if you did them. A theory is an explanation for an outcome. It's generalized, right? So it's about elections, not just about this election. Cumulative, so it builds on prior theories, prior explanations. It can be wrong, right? So it's not a theory, a scientific theory, unless it can be wrong. And it should be causal, right? So it should tell you why something is happening. So, this is where you go after you go, causation doesn't imply correlation. If you're the smartass that points that out to some senior stakeholders, you better back it up with something that can help them. And the thing is, causal claims, mechanisms that link a process to another process or outcome. And so it's theories that generate testable hypotheses. So A/B testing is not theory, right? That's just, I changed the button from orange to green. Did it have some effect? And then we're going to change it, and then we'll change it back again later, because we have no theory of why the color of the button changes people's behavior in any profitable way. So theories are comprehensive explanations of the thing that you're trying to explain, predict, influence, and you get hypotheses out of them. So that's, we don't have time to do that. We've got to deliver our churn model next quarter, otherwise we're all toast. Well, you do have time, because everyone who's asked you to do this already has a theory in their head, right, about, in the churn model, what makes customers join us, what makes them leave us. All these gold mines of a potential coherent, comprehensive explanation. They're just sitting around you. You've got to talk to them, though. That's the trick. So come out of the computer and talk to people. You've asked me to predict why customers leave us and when. Why do you think they leave? People will have bits of a theory that you can assemble together. Another thing you can do, sketch a toy model. So this is borrowing from econ, game theory. So this is always illuminating. Who are the actors involved in the situation? Us, the customer. Is there some other actor? Your competitor? What are their objectives? So what do we think each of those actors is trying to achieve? Given that, what options do they have? What actions can they take? How do they play the game? You can formalize this into a full-blown game theoretic model, or you can just answer these questions in human language, and you'll still know more than you did. And then, importantly, how do the actions of each player affect the others? Right? That will illuminate things like, in our churn model, we want to understand the marketing campaigns run by our competitors. That will give us a better model than if we don't. And that's because this is all thinking before you look at the customer and before you join the customer and the order and the product table together. This is stuff that you can do beforehand. Okay, not quite as good as a comprehensive theory. It's called a toy model for a reason. So in my dissertation in political science, I had a massive wordy theory chapter that boiled down to this single toy model example that is what explained the entire thing I was trying to test, and then these Greek letters gave me my testable hypotheses to then take to some data. But you don't even have to put it in a tree. If you just answer those in English, I guarantee you'll now know more than you did, and you'll be less surprised or less thrown off by strange things you might find in your data. Okay, not quite as good, but other people who are not trying to solve the problem you are trying to solve probably have expectations about what the solution is or what the data is. Use your data science colleagues, explain what you think you're doing. So these aren't formal hypotheses, but they're still very useful. And then last but not least, what we're trying to do in data science, right, whether we're explaining or predicting, is to recover the data generating process. Very statistics. Some of you may be having episodes going back to Stats 101. The data generating process is what made our data happen, and if we can approximate that with our model, that's what leads to good predictions. Right? That's what a model that's learning a pattern is actually doing. It's reproducing created data. Exercise in resisting temptation is data science. Don't look at the data and try to work out how the data was generated before you see it. What that does is make your assumptions clear up front before you pollute them by writing SQL queries. So, the most important things you can learn about your data, you cannot learn from your data, but you can learn them using this thing called science, which is this second word hiding in the name of the field that we don't talk enough about. This is where you can find me, and that's it.